The next reference guide we'll be looking at is reference guide 4 from Unit 6, and it deals with our second form for expressing the equation of a line, which is point-slope form. We talked at the beginning of reference guide 3 how there would be 3 forms we would be looking at for equations of a line. We've already talked about slope-intercept form. This is our second. It is point-slope form. And point-slope form is a way of representing an equation that indicates the slope of the line as well as any one point through which the line passes. This is nice because it gives you freedom in terms of what point you're looking at to go along with your slope. What I mean by that is in slope-intercept form, it was slope and it was y-intercept. So if the line goes perfectly through the y-axis, meaning it goes right across the grid, right through a number, then slope-intercept form is pretty straightforward. You just pull that number off and find your slope and away you go. But if it doesn't go perfectly through that, then there needs to be another way that you can express the equation of a line. And this is that other way, or one of the other ways. It's point-slope form. So you'll notice the format of point-slope form is listed here. The line is, or the expression goes, the equation, sorry, goes y minus y1 equals m, and then in brackets x minus x1. Let's start with the one that will be straightforward because it's the same as it always has been, which is m. M is still your slope. You'll still calculate m the same way that we have been, y2 minus y1 over x2 minus x1. You may need to calculate slope, you may not. It will depend on the question and whether you can count or you have to calculate slope. But regardless, that's the same as it's always been. But now we have this y and y1 and x and x1, which gets a little bit more confusing. So we can see kind of what we're looking at here. When we're looking at just x and y, those are going to be any points on the line. What that means is your equation will always have that y and it will always have that x. From the graph that you're given or the line that you're looking at, you will be able to pull out one point. It may be an intercept, but chances are it won't be. And that's what this y1 and x1 means. That is the coordinates of the point that you are pulling off of the graph. And we'll see what this looks like when we do some examples. The thing that I want to really call your attention to, and this is, we'll talk about this in more detail as well, is what lies between the x and the x1 and the y and the y1, and that's a negative sign. And that's going to change the sign of the coordinates of the points that we know. We will look at this more closely when we do some examples, but it's just going to make everything seem like it's the opposite of what it actually is. And again, we'll look at that in a second. Okay? But that's the form we'll be using. Y minus y1 equals m bracket x minus x1. If 2 points are given on a graph, but the question asks for the equation in point-slope form, we will calculate the slope, same way we always have. And then you can use any points from the line, and that's important. What that means is you may choose a point, I may choose a different point, someone else may choose a third point that's known from the line. We may plug those into the equation, and we all could have the same equation, even though our numbers will be different. It would mean we just all chose different points. Again, we'll look at that in a second. So let's look at some practice problems. So describe the graph of a linear function with the equation y minus 2 equals 1/2 x plus 4. Again, let's pull out what hasn't changed, and that is our slope. So m is our slope. It goes before the brackets containing the x's. It's the first thing that appears to the right of the equal sign. So our slope is 1/2, and you can see that written right there. So that's our first descriptor there. Slope is 1/2. But now we have to look at what else is going on here, and there's an interesting thing that's happening. So we have y minus 2 and x plus 4 in our equation. This means that it passes through the points -4 and +2. Well, if you look, those are the opposite of the signs that are in the equation. The equation says -2 and +4. So why is it going through the point -4 and +2? Well, again, that's where we have to go back and remember that it's negative. It is y minus y1 equals m, which in this case is 1/2, so let's just write that in, x minus x1. Well, in order to get y1 to be minus 2, that means that it has to be plus 2. It's just y minus 2, which is what we can see up here in the equation. On the right-hand side, in order to get x plus 4 from x minus x1, well, x1 has to be a minus, because we know that subtracting a negative gives us a positive. And then if we simplify this all, we get y minus 2 equals 1/2 x minus minus 4, which is where that plus 4 comes into play. Okay? So it is the opposite. So when you read the equation, when you're identifying the coordinates, so if it says y minus 2, that means your y coordinate is plus 2. If it says x plus 4, it means your x coordinate is minus 4. And that's to account for the negative signs that appear in the equation of the point-slope form, or of point-slope form. Okay? It's an important distinction because it's the opposite of what it appears in the equation. Okay? So when we describe that linear function, y minus 2 equals 1/2 x plus 4, we know that a point lies at minus 4 comma plus 2, and we know that it has a slope of 1/2. So now let's move on to the second question. Write an equation of the graph below in the space that has been provided. So we have a point. We know point P is negative 2 comma 5. And they've labeled another point, point Q, but that's not helpful. It's kind of in the middle of the grid, and it's just been labeled with coordinates x comma y. But we don't need that. This is where this form is nice. If we were trying to do this with slope-intercept form, well, we would calculate the slope, and we would see the y-intercept is at negative 1. But it's asking it, or we're doing it, sorry, in point-slope form. So we know this point. We know the coordinates of point P. We have to find another place where it passes through the grid, because we're going to need to find the slope. Well, it passes through right there at the coordinates of negative 1 comma 2. So we're going to use this information to come up with our slope, and then we're going to plug in either of the points that we know, probably point P because it was given to us. So let's start with the slope, y2 minus y1 over x2 minus x1. So we'll go 2, subtract 5 over negative 1, subtract negative 2. And it gives us negative 3 over plus 1, which is, of course, just negative 3. So we have a slope of negative 3, and now this is where point-slope form is very nice. You just pick any point that you know. Well, we know negative 2 comma 5. We know negative 1 comma 2. And if we wanted to go even further, we know 0 comma negative 1. We know all of those points. They pass perfectly through the grid. Pick any one of those points to plug into your equation. So let's go y minus y1 equals m x minus x1. Our y stays. That will always be part of our equation. Minus y1. Well, let's choose this point up here. Just for simplicity's sake, that's the one that was listed, so let's use it. Y minus 5 equals negative 3. X minus 2. So let's simplify that. So our x coordinate is minus 2 for point P. So let's simplify everything. Y minus 5 equals negative 3. X minus minus 2, subtract minus 2, is plus 2. So that is an equation for this line. And now, I just want to look at something else. Let's say that that was the one I had chosen, but you chose to use negative 1 comma 2. So your equation, which I'll do in blue, would work out like this. It would be y minus 2 equals negative 3 x minus minus 1. When we simplify it, we get y minus 2 equals negative 3x plus 1. Different numbers, but that's the equation, or that's an equation for the same line. Both of those are perfectly fine. So the point is, it does not matter which point you choose on the line. There are multiple correct answers. There are multiple ways to express the equation of a line in point-slope form. Now let's move on to the second page and take a look at some more problems. So for the graph below, write its equation in point-slope form. So to do this, we need to find some points. We're also going to need to come up with the slope. So let's pick our points. This one would be at 3, 1. This one would be at negative 1, negative 2. Again, when we do our equation, it doesn't matter which one we choose, but before we do that, we should find our slope. So when we do this, we're going to go 1 subtract negative 2 over 3 subtract negative 1. That will give us our slope. So 1 subtract negative 2, that's 3. 3 subtract negative 1, that's 4. So we have a slope of 3 over 4. And again, if we want to make sure that that's right, we can count. Up 1, 2, 3, across 1, 2, 3, 4. So our slope is good there. So we have our slope. Now we need to write our equation. We'll do that in blue. So the equation, y minus y1 equals mx minus x1. So we choose any point. Does not matter which one we choose. I'm going to choose 3 and 1. So y subtract 1 equals 3 over 4, x subtract 3. And there's our equation for the line. Again, if you had chosen a different point, let's say you chose negative 1, negative 2, we would get y minus 2, which we'll fix in a sec, 3/4 x minus 1. Well, then we wouldn't leave y minus 2. It would become y plus 2 equals 3/4 x plus 1. And both of those are fine, as we talked about before. It just depends on the point that you choose. Neither is incorrect. All right. So we have one question that's left, except we need to calculate the y-intercept for question B. I forgot that one because I spilled into that space. So for part B, calculate the y-intercept of this graph. Well, this is where it gets a little bit more complex with your algebra. So to do this, we know that the y-intercept occurs when x equals 0. So we're going to choose either of our equations. I'll use the one that's in red, but you could use the one that's in blue, and that's fine. And we need to go in and make x equal to 0. This is going to be some different algebra that we have not seen before. So let's do that and see what happens. So I'm going to go into my equation, and where I see an x, I'm going to plug in a 0. And let's simplify. So y plus 2 equals 3/4 multiplied by 1. Well, that's not too bad, because anything multiplied by 1 is itself. So y plus 2 equals 3/4. Now, we need to get rid of our denominator 4. We don't want that denominator 4 there. So we're going to multiply both sides by 4. That will give us 4y plus 8 equals 3. Now we have some algebra that we've seen before. Subtract 8 from both sides. Gives us 4y equals minus 5. Divide out the 4, and you get y equals minus 5 over 4. No need to make that a decimal. Leave it a fraction, and it's fine. And if you wanted to make sure that that's right, well, you can look up at your graph. Y equals minus 5 over 4 is going to be a little bit more than negative 1. So you look up at the graph and you look at your y-intercept. You find that, and we know that it should be a little bit below negative 1. Well, there's where it's crossing the y-axis. That's a little bit below negative 1. So we would be confident that the math we did there is correct. All right? And again, that is more complex algebra. You're going to be working with fractions, but it's fine if you're working with fractions. Get rid of your denominator by multiplying both sides by it, and then move everything over and divide by your coefficient in front of y. With that algebra, again, there's additional steps, but once you get to this stage here, it's algebra that you've seen before. Okay? So your first stage, plug in a value for x or y that's 0, depending whether you're finding horizontal or vertical intercept. Then get rid of your denominator, and then solve using some algebra that we have already done in this course. Okay, question 4 is our final question. We're going to write an equation for the line that passes through r at 1, negative 1, and is parallel to the line y equals 2/3 x minus 5. Well, we know a point, so that's good. We know that this can be x1, this can be y1, and we know how slope-intercept form works. We know that that's our slope, right there, 2/3. Well, if our line is parallel to a line that has a slope of 2/3, then our line must also have a slope of 2/3. So when we write this, y minus y1 equals mx minus x1, we know our slope is going to be 2/3. We know it's going to be y minus minus 1, x minus 1. Now we just simplify. Y plus 1 equals 2/3 x minus 1. Okay? Don't let the wording of this question fool you. You know where to find the slope if a line is in the form y equals mx plus b. If it's parallel, it has to be the exact same slope. So if it has a slope of 2/3, your line would also have a slope of 2/3. For part B, if it's perpendicular to a line of y equals 2/3 x minus 5, well, again, that's our slope. So if the slope is 2/3 and we want a perpendicular slope, we flip it and take the opposite sign. So the slope must be negative 3 over 2. It has to be the negative reciprocal of 2/3 in order to be perpendicular. Well, we still know our point, so the only thing that's going to change here is our slope. Instead of being exactly the same, it's now the negative reciprocal, but otherwise, everything else is exactly the same because we're using the exact same point. Okay, that is point-slope form. It's, again, a different form for expressing the equation of a line. It works really nicely because you can use any point from the line to use point-slope form.